all ready. Gentlemen, I think we are live. So we are going to test today the code that I didn't. I'm just a user. Basically, ChatGPT generated it. So yeah, no fancy thing. I'm a Reddit guy to go to. I use ChatGPT to generate my C for the STM32. But the main purpose of the video is, or the day or the progress for the day is that we wanna control the burner, but we need to be able to first use accurate data for the blower control, basically feedback, and we want to reject the jumpy data. Basically the pressure sensor is not just flat, it will jump up and down, and we want to reject the big jumps, and we use derivative filtering for that. And I am really curious that if the code works that basically he made. I used the previous snippet, and we'll see how it goes. I will just basically zoom this shit, or like, how to say this? Yeah, I will do that, whatever. Make myself a bit smaller here, and what we are going to do is that we're going to take a bit off from this, and what we are going to do is, here's the code. I will swap the camera, and maybe I will need to camera 0, and I will put my camera here for now. Here, my room is a total mess, so don't worry about that. So this is basically the current setup. The ugly duckling is here, and what we are going to do is that I am going to take my USB out, or pen drive out. I'm going to make a bit of tidy up here, so we can get it all over the place. So what do we have here? Wires all over the fucking place. What we need is this. I want to is this? I think it was, yeah, I think it was like so. Oh, oopsie. I have to check for the wire integrity. I need to put all this fucking cream pads and all these fucking branches and all this shit inside. Somehow I need to manage these wires as well. Takes a lot of tools, all this shit. USB, I'm not going to plug it just yet. Is this usable? Yeah. Good. Make it full screen. I wanna. We care about the whole thing, not. So yeah, it looks pretty consistent. Is to check for the wires first. Yes. These are on as well. Going back on. This is in as well. Alright, now we do have the pressure sensor. Take the wires here, so this is the high pressure pin. Okay, this is the low pressure pin. And here's the higher bit pin. So that the pressure sensor is not all over the place. So this is the green, so the power goes to here, because I always say this, but I have actually found out the design of the rotor of the blower, which is designed the other way around, so it is counterclockwise design, not a clockwise design, because the other motors were like that, but this isn't. So So very interesting. I need to hook the motor the other way around, and yeah. What I will do now is I will upload the IDE's code, and I think I will build it. You can see that the code has built, and you can put it onto the STM32, and waiting for debugger connection. You can see that the thing is blinking red, and now it's done. Shutting down exit, so we are done. Great. Now we can come in here and my favorite background, by the way. So this is the winter or Christmas cactus, whatever they call it. What is this? Don't care. Fuck off. Right. I don't need another monitor to see the chat if there is anything. Whatever, nobody is watching just yet. Fine. So right. So we have this, but I do not care about this. I want this. I want this. And it should be. Yeah. It's in the right com. I think we do have the right baud rate as well. So what we are going to do now is hopefully this shit will run and I won't have to unplug the things. I think it will run. Alright. We are actually running here, as you can see. We have okay, working nice. Okay. I don't know how much. We'll have to make this a bit bigger. Maybe here as well. I can see all the data. DT we will see. So basically what we need to do is send. Need to do this, and the other thing that I need to do is to hook up the guy. Move the soldering iron. Alright, plugging this. Yes, this is done. Right, so it turns on. Great. We require a paper tissue. Alright. This is ground. And this is how this one. Hooking it up. 6 or what is this? 12 volts. 12.3 because there is the 0.3 volts of internal loss. But yes, this is going to be powered. Put on, but there is a bit of voltage and amperage draw because the capacitors on here need to charge up as well as, I mean these don't, but or maybe they do. I don't think so, but these do. So what I will do now is I will write in. Make this a bit bigger because alright. Come in here, send. We can arm. So acknowledged, and basically now that we have armed, I will be. You can see the light here. That is green. It indicates that the system is armed, and when I push the blue button, then the relay should open, and we should see a tick. Right. Great. So that works good. If I disarm it, then the LED no longer is active, and if I push the button again, it cannot do anything. Yes, nothing. Great. The other thing is send. Do this. What is this called? I think it is called blower. this blower and let's set him to 30%. Alright. You can see the 12 volts and you can already hear the blower working. He's spinning a bit wobbly. You can see the inner thing there. I will maybe come here and push this foil sheet under it better so that it doesn't shake as much. Alright. I will leave it here. Rejected one. I think we have got some problem. Or maybe this state one. Reject one. I don't know what this means. I really hope it just means that the reject one was that is that it rejected only one, not the whole data set is rejected. Probably I will make it bigger. Whatever. So, or maybe I will put it here. Maybe I will put it there. So basically, yeah, 30%. I think it's going to be alright. I will step it up to 40. Boom. So state 1, reject 1. Maybe this is just that it rejected the whole data set. Field. We have to take the whole set. Whatever. I will Control C, plug it into a TXT. Nothing interesting is happening right now. But alright, video. I think I will do this. Hello. Alright. So okay. What I will do is that I will leave this here. Okay. The other one. The problem is that I would need a fucking second monitor, then I can do this. But, I don't know, how are we doing? 40, I think it will be alright. Will be 50. Maybe this rejected, I'm afraid that the rejected is that it rejects all the data, which could be, because it detects the jump from, maybe, I don't know, we'll see. So, yeah, I will open the thing here. Bitch. So maybe just this. But this doesn't, yeah. Hooray. So, yeah. I can see everything in here. I can see the data as well. Pretty good. State 1. It's pretty stable. It is jiggling a bit, but I think it's pretty normal. 8 watts of power. Alright. Or maybe do a side split, side screen, but that looks terrible as shit because of the compressed bullshit. Whatever. I'm going to step it up to 60. Let's let's say 10, 9, 8. Let's go to 5, 6, and 7, basically 5, 7. All right now. What is this? Is this the whole thing? Great, very well. It glitched out the fucking thing. I didn't even look at it. Very well. What the fuck? ADC reads 2000, ADC 0 reads 2000. 2100-ish. Let's see with 70. 60, 570 was 100 cent. Let's go with 70. It goes up. But I don't get it then why the fucking DM. Maybe it is because this dumbass fucking retard dumps all the data out because of, yeah, it's rejected. Therefore I will not. Whatever, you can suck my cock here, I don't care. At least we can see that this is not working. The main point is that, I put that for on, that the P row is visible here, which I don't know why the things, yeah, probably because it is rejected, that's why. Whatever, we'll go with 70. We'll step it back down to 65. Or you know what? Let's go to 75. At 70, so it's 19 seconds. Interesting thing is that I don't see the other panel, which is kind of annoying. Oh, actually, welcome to the stream. If I don't know if I can see if anybody's writing something. This there is like a bit of a delay in the stream, so yeah, I apologize for that. Whatever. So now I'm actually testing the blower, and I am testing on different duties. Basically I can command with send. This is the 75% of the whole thing, and now we can see in here that the wattage is higher, 41.2 watts, and you can see that the underfoil is wiggling quite much. So whatever, I think this is 75%. Right, we're going to go to like 870. Let's go to like 850, I don't care. We'll go up to 85, then we're going to go down to 65. We're going to go to 80 or 50, yeah. Yeah, you can see that this I'm just curious about the ADC for now, and then I will test for the VDD, VDOT, and all this kind of thing. Now it is rejected all the fucking time, which is kind of annoying. 25 sec. I think we'll do till, let's hope till like 910, because that's going to be 16 seconds, so a minute. And I will go to maybe 85. I don't know what the VDDAs are, 20, 40, 20, 10, 50, it's kind of jumpy, yeah, this is kind of jumpy, not gonna lie, 10, 60, yeah, this is kind of unstable. I'm going to go to 85, I'm going to go to 60, 65, I'm going to go back down. Yeah, this is kind of a lot, but it is not too stable in terms of, I think, let's go 85, I just will test it to see if it is like stable, but I don't think it will be. It is kind of jumpy even now. Look at this. Kind of stable in terms of wattage, it's 50.9, 51.5-ish. What's the P? Yeah, 260. Yeah, 260. It goes down to 260. It went down to 230 once. Looks 250-ish to like 200. I mean, 23 something. Alright. And the ADC is all over the fucking place. Yep, we'll do a 65 now. Now it will be probably a bit more stable. Yeah, you can see 20, it goes to like 20 to like 40, so it's a 20-ish jumpy. And up to 60 once. But it is pretty stable. Yeah, so at max like 40 jump, 40-ish range, which is what? 40, 2.5% or something like that. That's pretty stable. The other one was not that much. We'll test this, then I will go down to 55 to see the data. I don't care about the data not being complete totally, I don't give a shit about it, that the DHMM, basically the volumetric flow and the differential height of water is not correct. I don't give a shit about that. That can be read if I will test it with a few readings. I will not have to go through the whole thing. I just care about if the system is working. Alright, if the data is reproducible. Yeah, going down to 55%. Dying down to 25. It's pretty bad in terms of sound. This sounds even worse than the fucking... This even sounds worse than the previous one. Ooh. Pretty bad bass noise. Whatever. Alright. Looks pretty nice. Alright. I think I will do a 45, and that's a bit more sustainable in terms of noise. This 55 is very bad. So, welcome to the stream. I'm actually testing the blower as well as the STM32 is running the whole thing, and here on the PC side you can see the data here that is being read. Actually testing that I read the ADC, that there is like a pressure sensor here with the reading the orifice plate here. You can see the orifice plate, two pressure thingies. This is the higher pressure, this is the lower pressure. The difference pressure is basically proportional to the amount that the blower can produce of flow, basically liters per second or whatever you have, CFM, whatever shit you want to measure. And now I'm just testing that the data that I read via the pressure sensor is actually being rejected or not, meaning that you cannot read every single data, because you can see that there is like what is this? It's like kind of stable now around 2020, 2030-ish, 2010 to 2030-ish. But when I was running it on 80%, then it was basically shooting all above and like all over the fucking place. It was deviating like around 100 ADC, which is kind of a lot. And basically when you have big deviances, then you have this filter in the code that basically rejects these big jumps from very intense big jumps. Basically like a filter to not get and not gather shit data. And that's the point. Now it actually doesn't work because every line is rejected, so that's why this V dot, which is basically volumetric flow, and the difference in pressure in water millimeter is actually stuck, but we don't care about them now. I just care that the whole thing works, and it seems that it works. I will have to correct the rejection methodology, and I will stop the whole thing now. Does e-stop work? Yes, e-stops works. Okay, great. Alright, and then we will stop the guy, unplug the connector, and how do you say this, make this shit smaller. What the fuck? So put him into the corner, maybe smaller. What I will do is I will first of all this power supply so it doesn't heat up the guy. Alright, we have the code run nice and stable. Use this ChatGPT here. So burner. Alright, and we will go into the IDE, which is this. I think the problem now is that every single data is rejected. I do not know why, but I have a strong feeling that it has something to do with the fact that we do not use it's probably with the median or something like that, whatever. So we have a filter, a low pass filter that we use to actually reject this shit data with like a with this we collect median, basically we calculate out the average data, but I think this is the it's not that. I mean, maybe I can collect all. Yes sir. And create a txt indices. Maybe I will make another one. All right. Rename. What is this? Test for burner. Before burner. what is this? The meter height and the v dot is not updated. We'll need the ID code as well. Yes, I am just going to copy C, Control V this. I'm not going to lie, I do not know what I'm doing, kinda. Why do we have two of this? Very annoying. So what I wanna do is that I wanna correct this thing. I mean, I don't know. Yeah, so basically this is the STM32's interface, which contains the code of the whole thing. I'm not going to lie, I didn't make this. This is fully ChatGPT generated, and sure, it is not just one trial and error. It was a lot of integration and continuous iteration to basically put everything in. So basically I can disarm the relay that's on the board, and yeah, so whatever the do the work. Fuck off. This is very annoying. Very annoying. Bernard. Let's see what the problem is. Oh, great. Great. Okay. Great. Okay. Yes. Innovative correction. Pay filter. Maybe I can make this to the side. Doesn't matter. Fob rejected equals 0. So this is kind of the rejected block. Oh, fuck off. So okay, here it is. So where are you? Okay. Yes, if rejected. Oh, this is why. Oh, I need to do and replace this. Yes, corrected pressure instead of the replace this part. Okay. As if have prev have as, I think this is, yeah, here is the base med p rho minus base med, and I want to have the whole thing changed, even if rejected. So basically I can control C the whole thing. Is this corrected pressure? That's corrected pressure here. I think this is which one is this? I think this is this. If who has this? This is this. This is this. Okay. So we do not care about the whole thing. We can boom. Bada beep boom. I'm not sure. We'll see. Let's build. Alright, it works. So what the fuck does this do? So basically we calculate P corrected with the P rule, basically with the median. And this is going to be the corrected. Alright. Field P core. Okay, prev P field. Yes, have prev 1. Alright, we'll see. Study non-zero DP real flow is non-rejected anymore because once P filter track sitting of stays small, sudden glitch spike produces large involve and gets rejected. Okay. Are data recycled based on P filter which either advanced or had also raise gate min or is too small for your PD. Gate min 3 if your orifice produces. Oh, I don't think so. Gate min, I think we will see what the gate min was. Gate min, is it printed here? P row, gate min. What is this? Gate min is I think this is kilopascal, right? So this is supposed to be yeah, this is too small. Seven. What? How the fuck is this? Oh, this is the 70%. What the fuck is this? Hello? Where is the other data? Hello? What? 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 Where the fuck did the data go? Come on. Let's start this shit then. We have to plug it in anyways. We'll see what the base data is. Yeah, let's just go. Connect, run the thing. Yes. What's the base data? 19. So it is. It's not rejected, but it is state 007. So yeah, I think 3 is a bit low. 6, 7, very well. So yeah, 008, I would take it out to 008. Where the fuck is this? what do we call this? Gate min. Where are you? Let's see. Alright, I will hammer this out, meaning that I will build it. And now, hopefully, we have no errors. Plug it onto the board. Alright. Reading data. I think it takes like, I don't want to say bullshit, but I think it takes like, what was it, 30 seconds for the baseline reading. So it should be getting into state, yes, state 1. Alright, we are done. So we can do the blower command to 30, but first I will turn on the power on the rope. Let's go. Yes, V dot is 5.8, 5.4, 5.7, yeah, 5.4 dash 5.8, 5.9, 6. A bit jumpy. It's not rejected. Right. So all right. We are going with 30%. Let's go to 40. Then I will step it up with. There is basically no rejected, which is kind of interesting. ADC. Maybe I have set it up too much. Alright. This is about 7 liters. 7.5 liters ish per minute, or per second, sorry. We'll go with this for another 20 seconds to like 200 sec, and then we will deviate to 45. let's go to like 20 and then we will do it. Boom, boom, now. Alright. This is 8 liters. 8.5 liters. Let's go to 50. Oopsie doopsie. 50, 50, 50. Alright. I think I did it at 30 or 20. Let's go to like 20. Let's go on it and go up to 50. Yeah, okay, to 280, which is a minute. Boom. This is 9 liters ish, 9.3, 9.5 liters. Okay. 55. 80, that's 340. Nothing. This is the least interesting of the whole thing. I just need to test the guy. Then test the guy up to, I would say 75%. I don't need the 80%, that's too much. Alright, 40, 60, 40, that's 20 again. Or is it fuck? It's 400. 400. 400. Yeah, this is the least interesting thing. But it is needed, because otherwise you will not be able to do the further, more fun testing, so to speak. So yeah. 8, 7, 6, 5, 4, 3, 2, 1. 60%, 65. So 460 is the next one. Is anybody doing anything to have this shit? I don't know why. Why is this not like how do you say this? Like why can I not like see this? Very annoying. Tessék! Be right back. Micsoda?
Mi a kurva anyádat csinálsz ott, hogy Mizu?
A ventilátor.
Baszol rá.
Hát jövök, csak...
Hiszem, hogy a mikrofonnál megint behagy.
Nem.
Házol a térnek.
Azért, mert nem hallod, én beszélek.
De akkor kapcsold azt a szart.
Mert tesztelem. $65. Actually, we have the blower. I'm testing the. I mean, I can make it a bit bigger. So you can see the blower here, power supply. This is the pressure sensor that measures the pressure. This is the STM32, this white shit here. And my PC is connected to it, and I'm actually reading the live data here. You can see if I minimize this, we can see that the data here, time, this is state, which is basically that the pressure has been measured. There is like initial state that I do to measure out the baseline, because the pressure sensor deviates some, and then when the baseline is captured, then we basically median, it's kind of like mean, but it's median, and then we take the median of the last few samples and then extract, or like what is that, subtract out the baseline data, and we get a corrected pressure reading that we calculate the amount of flow that we have. This is liter per minute actually, or second, liter per second. So this is 12.3 liters per second roughly that we are pumping now. We set the guide up to 70% because I think we have been fine with that. 38%, 38 watts ish of power drawn, pretty stable, around 1.1.2 watts of variance. When I say that it went up 5.5, whatever. We'll set it to 75 next time. Now we produce 13 liters per second, which is kind of a lot. 13.4, 13.2. So yeah, pretty good, pretty good. Yeah, this is not the most interesting stream, I guess, I suppose, but if you have any question, you can dump it in the thing. I think I will be able to see it, though I'm not entirely sure. Alright. Alright, I will start the music. Not this, not this. I need to find something. Let's go with the Tura. Yeah, this one. Liters. 14.2 liters ish. Pretty nice. Love it. Drawing 40. I wonder what the 80% can do, but that is pretty shit because it is jumping quite a lot around. You can see that this is jumping. 14. % will be the last one, but that's going to probably be a bit shit because there is a lot of disturbance and all that kind of stuff happening, which makes the whole thing vibrate, and it doesn't do it any justice in terms of flow. Alright, fine. I will take it to like 7, let's go 770, because that's like a nice number, and then we are going to increase it to 80, see if it is having any rejections. It doesn't seem to reject any data, which is kind of interesting. 15.2 to like 15.5, 15.1, around 15-ish, 15.1, 15 to like 15.5, so it's half a liter deviance. That's not that bad, I suppose. It's not the best, but it's not that bad either. I think this 80% is still doable. I will measure it to like 70 plus 60. What is that? 30? Yeah. Then I will e-stop the guy. Does it work with small numbers or small letters? Yeah, it works with small letters as well. Alright, sure. Nice. Nice cock. Yeah, the power supply got kind of hot, so it's turned its thing on, but I thought so. I will take the readings down. Disable the guy. I will, hopefully I will be able to extract it, not just the last few data. It would be very annoying. Oh please God, please. What's this? Let's see where we start from. 300, 200, 230. What is this? Oh, please. Fuck me. I need to fucking fix the... CDR port. Is this something? What is this? Ruined. Yeah, can be jack shit with that. I don't have any fucking data. This is double, but it is empty. Fuck. I need to fix this as well. Yeah. Which is kind of sad because I lost a lot of data, but whatever the last few will be still meaningful. Do this, insert this. Alright, rename it V2. The fuck is this? Why is this not working? Alright, just looking at the analytics, doesn't matter. Just curious if they. What is that? People are chatting or some shit yesterday. So there were people who wrote and I didn't reply. Felt kind of shit, to be honest. What is this ChatGPT? Oh, alright, good. Let's see. This doesn't work at all. Sign up figure. This doesn't need to be here. Rate. Now we can take this HRC field. Yes, mode log line. Oh, it's not even here. Great. serial port baud CRLF flush. I think this is done. Alright, feed. Is this flush? I'll put this here. Terminator. Let's see. This isn't working either. No, it's not working because this fuck. Any of this should take on bigger size. Very well. Doesn't work. Yeah. Just Terminator mismatch LF versus CR versus LF. Alright, let's see if we do this. Does it work then? Doesn't work. Maybe I should. Whatever. What's up with this? Alright, it's off. Is my... Yes, my hand is in here, okay. I will take this guy here and just put it in the background. I don't care about him for now. Deal with him for now, he's not needed. I think when I will go to go and update the code now. Hopefully it will work. If not, then I will take off for the rest of the day. Honestly, it's just 6:30, but I'm big to death at this point. The thing that I wanted to test is that how does the maybe I will take out the camera and live a bit outside to test the blower there, or not the blower, the pumpy, basically. Take off the blower and I will take out the board and I will test the pump and how it works, if it heats up the wire or something like that, and then I will go and take off for the day. I just want to test if the pump works or not. Yeah, this should be closed, and then the next one should be where is this opened? The volume off a bit. Burner, fuck off. Connection error, alright. What's going on? Residual filter. Res-id P-core filter. Rejected. Res Fobs rejected because let's see. Rejected. Where the fuck is this? Rejected, here it is. Innov. We are using Innov now. I don't know what that is. Static float, res-id. I mean, let's see what it does. P-core minus P-field, that's the same thing, just we call it differently in Nov. Fobs rejected, it was Fobs 8. I don't know what this is. P-field. Yeah. Oh, okay. Let's see. Great that you freeze. Alright. Let's start. Let's see if it works. Does it update? I don't see anything updating. tpfv.reg. This is not what it is called. This is called reg. This is called v dot, which is not called this, which is called, oh, it is called v dot, okay. pf, what the fuck is that? I don't think that there is a pf like that. V dot, I don't know what pf is. P field, actually. And T is small t. Run now. Fuck off. Using serial. Fuck you then. Plug it on. Will you run now? Doesn't seem to fucking update this. Dumbass. Where the fuck do we... Yes. Function or line HRC. TPF, this doesn't... great. I don't care about the fucking blah blah. Great. Name handle. Great. Very bad. Yes, resid. Ref prev. Yeah, I think this is how it works now. Pay field res gate in of float ref. Do we take the pay field? Pay core minus ref. What is ref? Oh, this is ref. Alright. Pay core minus ref. What is ref? Have prev pay field. PWMs. Ref. The great shit. Innov. We will call it Reside. Alright, Resid. Let's see if this works or not. If not, then I will redo it. I will use this as is, and I will just take the fucking. I will just quit now. Yes, I know. Can't end on a lose, can we? I mean, we can. I don't really do shit. Just take off the rest of the night. I'm pretty tired. I think that was it for today. I have to edit this tomorrow. Terminator fucking thing, whatever. Thanks for watching. I will just drop out now. This was it for today.